We'll proceed summation to integral. Okay, so we are pursuing discussion on summation summation to integral. Summation to integral. If I have summation of items, then how I can transform into integral calculus? If I have summation of items, if I have so many summation of items, then how I can move it to integral calculus? Why it is required moving into integral calculus is because summation are too many. Too many in a sense that, okay, so like we, okay, up. Okay, very heavy. Okay, consider this is a sphere. Up. Consider this is a sphere. Okay, consider this is a sphere and we are trying to calculate the surface area of the sphere. The concept is how I calculate the surface area of a sphere. Considering considering this is a sphere. If this is a sphere, then how do I believe it is heavy and it is okay? I'll take another sphere. Okay, well-known sphere. Consider this is a sphere and we are trying to calculate the surface area of the sphere. How I can calculate the surface area of a sphere? That we brought the concept from calculating the circumference of a circle. How to calculate circumference of a circle? Okay, in that fashion, I can divide the circle into many parts. Okay, how to calculate circumference of a circle is is we divide the circle. How to calculate circumference of a circle is we divide circumference into many parts and in n part, and then we add all the part and we get the circumference of the circle. This is also called repeated summation. Means we sum we sum up all the uh, all the sections in the perimeter. This is perimeter of a circle, and I divide this into n part. First part, this is x-axis, and this is y-axis. This is x-axis and this is y-axis. Now in that fashion, from x-axis I start radius and radius moves like this. And along the radius movement, we divide into many parts. This is the first part, second part, ith part, and like that n part. Okay, what we are dividing is we are dividing the circumference, and in that fashion, it is making where the angle that is 2 pi. Right now, consider it is 2 pi. That is 360 degree. The angle is 360-degree, and angle is divided into many angles, whatever it is. We are in a phase of calculating the ith section circumference. If there are many sections, what is the ith section circumference? Now, all part, if I add, then it becomes, if I add all the part, then it becomes the circumference of the circle. What is the ith section arc is when we saw further, then ith section arc, okay, when we saw further, then ith section of the arc, if this is x-axis and radius is moving like this, then this is the ith section. The ith section arc is radius into angle. If you see theta I, delta theta I, means this is the ith section of the circumference. This is the circumference. This is delta theta I. If it is delta theta I, then r into delta theta I is this circumference. Okay, this circumference is r into delta theta I. Okay, now r into delta theta I is the circumference of the ith section. I summation sign sigma sign summation sign I equal to 1 to n area of the ith section, that is radius into delta theta I. Later we saw that if radius is function over theta, then it would not work. In a way, in a manner, if this is the radius, this is the angle theta I can say this is angle theta I from the x-axis, and this angle is delta theta I. Okay, in that fashion, if this is the radius, then this arc is r delta theta I. If r varies with the angle, there are cases where r will vary with the angle. In that fashion, if radius is from delta theta I, ith section base angle is delta, I'm sorry, ith, this is the ith section. From this radius to the base x-axis, the angle is theta I, theta of till the ith section. This we can say like that, theta I. But actually it is not theta I. If I divide into n part, and considering full x angle is 2 pi, then each section has angle of 2 pi by n. If we start the ith section, then here the angle would be 2 pi by n, 2 pi by n into I minus 1. That is the angle that we are saying theta I. 2 pi by n is angle of one section, and then into I minus 1 into I minus 1. I minus 1 section. What is the angle? Okay, like if I say this is my this is my second part, then this is the first part. The second minus 1, that is 1. Pi by 2 pi by n into 1, that is the angle from here, whatever it is. Consider theta I. I am denoting it as theta I. If it is theta A and this is radius is changing if I move the angle, then next time radius can be smaller also. In that fashion, if I say r delta theta I, that will be this r, not this r. In that fashion, we went ahead and then we talked about a fundamental called delta x, delta y. If this is x-axis, then movement from point this to point this is delta x. Point this to point this is delta y. This forms a triangle. From here, from here to here, delta x, here to here, delta y, and this is the hypotenuse, that is the arc. If this delta theta I is very small, then arc I can consider as a straight line. Now this hypotenuse straight line arc is delta x square plus delta y square root. Now ith section this works everywhere. If radius is not changing with the movement of angle and both radius are same, and this is the arc, still delta x whole square plus delta y whole square root is this arc. So this concept works everywhere. Now we have summation I equal to 1 to n and square root of delta x of the ith section whole square plus delta y of the ith section whole square. This is the area of the ith. This is the, I'm sorry, this is the perimeter of the ith section. If I have termed area, that pardon me. Yes, this is the perimeter of the ith section. So perimeter of the ith section is delta xi whole square plus delta xi whole square plus delta y bottom right subscript I whole square root summation I equal to 1 to n. Okay, it is all right. Now, okay, now for a sphere kind of case, if I want to calculate a surface area of a sphere, then consider this sphere is centered at the origin. This is xy plane exactly at the middle. Top is above the xy plane and below is below the xy plane. The center of this sphere is 0, 0, 0. That is the origin. Now I want to calculate surface area of this sphere. In that fashion, if I take any point P here, whose coordinate is x, y, z, and from center, if I draw a line passing through this point, that will be position vector. Anyway, why we are calculating the area, the circumference of the circle is at this point. At this point, let's draw a line. We have talked in the past video. At this point, let's draw a line. Let's draw a line, and that line, make sure that this is x-axis, this is y-axis, this is z-axis. Okay, this is x-axis, this is y-axis, this is z-axis. Now, in that fashion, there is any arbitrary point here called P. P is arbitrary point here, P. Then from P, I draw a line, and that line go and come back and make a circle. If this is a sphere, it will make exactly a circle, considering y should be constant when we draw like this. Y should not change. And at point P, again I draw a circle like this and make sure that x will not change. X is constant. Now we have two circles, one circle and another circle. In that fashion, at point P, if this circle, now this circle where x is constant, I cut it into n part, and this circle where y is constant, I cut it into n part. The ith part for the both circle where P lies, the P point x comma y comma z. Okay, if I want to calculate the area at point P, then the ith section in this circle and ith section in this circle, if I multiply these two, then I'll get area. Area means multiplication of two sides. So at any point P, this is the circle that I got when I keep y constant, and this is the circle I got when I keep x constant. This is point P. So ith section, if I cut the circumference, the ith section is from here to here. Okay, and the length of ith section we know that is, if y is constant, the length of this ith section is delta x whole square plus delta z, because this is z axis and this is x axis. Delta x whole square plus delta z whole square of the ith section, square root. Now, if I take this circle, then from this point I take this line. That is the ith section here also, and length of this line is delta y I whole square plus delta z whole square root. Make sense? Now, in that fashion, the area of this abstract area, not the concrete area of this part at point P, multiplying this ith section and then multiplying this ith section, area of this part is delta xi whole square plus delta zi whole square root into square root delta yi whole square plus delta z whole square. If I say this circle where x is constant, I take jth section, not ith section, jth section. All right, take jth section. Now area, the pseudo area is delta xi whole square per delta zi whole square root. That is the this part, and this part, the length is multiplied by square root delta yj whole square plus delta zj whole square root. If I multiply these two, then I get the area. Okay, later we saw that delta x whole square plus delta z whole square can be a square root, can be renamed as magnitude of a vector, that is delta xi plus delta zk. If I have a vector called delta xi, delta x, not the ith section, delta x ith section I vector plus delta z ith section k vector. If this is the vector, then its magnitude is again delta x whole square per delta z whole square root. Means magnitude of a vector delta x whole square, sorry, delta xi plus delta z k, that is what is multiplied by another magnitude of another vector, that is delta yj plus delta z k. Okay, if that is the case, then I can take out delta x from the first one. Then it will become I plus delta z by delta x, delta z by delta x. If I take out delta x from here, okay, then it would become or I can divide this with delta x and multiply it by delta x. That also I can do. Let, or let's take out delta x. If I take out delta x magnitude and then delta x and in bracket I plus delta z by delta x k, where delta z is changing with respect to delta x, where delta y is constant and does not change. If delta y does not change, it is 0. Then I can put it here also. Delta x and in bracket I plus delta y by delta x. Because delta y does not change with delta x. Delta y is constant. If it is 0, I can place it. Who is stopping me? I plus magnitude delta x and in bracket I plus delta y by delta xj plus delta z by delta xk, where delta z changes with delta x. Okay, now it can be rewritten as delta x. Now delta x I can take out. Now right hand side we have again a multiplication where I can take out delta y and it becomes j plus delta z by delta y, j plus delta z by delta yk. There I can introduce a term delta x by delta y I vector. I know that delta x does not change with delta y, 0. So I can place it. Now delta y and delta x that I have taken out from these two sides, I can keep outside now. Now first one becomes magnitude of a vector, that is I plus delta y by delta xj plus delta j by delta xk into magnitude of delta x by delta yi plus j plus delta z by delta z by delta y k, and then outside delta x delta y is there. Make sense? Now in that fashion, if I see like this, that fashion if I see like this, wherever I see delta y by delta y by delta x, okay, then this is division, and this division delta y and delta x, delta z by delta y by delta x. Hope. I'm confusing somewhere. Okay, let's take it back. I have kept delta x, delta y outside. Now bring it back now. Now we have introduced delta y by delta x in first one and delta x by delta y in second one because it is 0. Now bring back delta x back into the first one and bring delta y into second one and settle it down. Now it becomes delta xi plus delta yj plus delta zk magnitude, and then another magnitude delta, if I multiply with delta y, delta xi plus delta yj plus delta zk magnitude. First one I can take out delta and it becomes xi plus yj plus zk magnitude. Second side also I can take out delta and it becomes xi plus yj plus zk magnitude. Kth section we are talking. Anyway, delta. Now in that term, first becomes delta p, because if I have a, we started a discussion that I have taken a point p, I have taken a point P here, and that is x comma y comma z. If from origin, if I draw a line, then that is position vector. What is your position vector? Xi plus yj plus zk. That is exactly like that. Magnitude delta of xi plus yj plus zk. That is delta p. Delta p. Okay, someone can say ith section, whatever it is. Multiplied by magnitude delta p again. But first delta p belongs to a circle that I drawn y as constant. Another delta p is a circle belong to a circle that I drawn keeping delta x as constant. Okay. Now if I have delta p, now I can redivide it by delta x and multiply it by delta x. Second one, I can divide it by delta y and multiply it with delta y. Now it becomes delta p by delta x. Here delta x is changing. In the first circle, if I see y is constant and delta x is changing, this is x axis, x is changing. In second circle, this is y axis and y is changing, x is constant. So first I can divide by delta x, multiply by delta x. Second one, divide by delta x, multiply by delta x. whatever it is. That is another story. Let's little bit go back. What we saw now, the theoretical area, the pseudo area, what we have got is magnitude delta p, that is the position vector, into magnitude delta p again position vector. Means position vector belongs to this circle in this section, and delta p, this is position vector. Okay, this this is the sphere and this is point P. From center, if I draw a line, that will be a position vector. If I take this circle where y is constant, then I take this circle where x is constant. Okay, in that fashion, if I take like that, in that fashion, if I take like that, if there is a circle where y is constant and this is point P, and there is a circle where x is constant point P. Point P is same in both lines. Now we have come to delta P, a vector magnitude of delta P, and magnitude of delta P. What is delta P? Delta P means I have taken ith section. If someone remember, if this circle, if I cut into n parts, what ith section of arc I have taken. If delta P means change in position vector. Now ith section, consider this is the first point here and this is second point here. If I if this is a center, if I draw two vectors, this vector and this vector, consider this is P1 and this is P2. P1 plus P2 will go middle of it and it pass like this. If I say P1 minus P2, it will go like this, tangential. So delta P is a vector that is tangential vector, that is along the line. So if I am taking an area where delta P is there, delta P, leave the magnitude. I can rewrite as magnitude of delta P into delta P. Delta P is a tangential vector in one circle at point P and another delta P. So I can say this is the ith section and in this side we have taken jth section. Delta P belongs to ith section in the first circle where y is constant. Delta P I am taken in the another circle where x is constant and that is jth section. Jth section. Now delta P ith section, that is the tangential line along the line, and delta P of the jth section, tangential line along the line. If this is the okay, if this is the tangential line, if this is the tangential line delta P, the first circle, and then this is the tangential line delta P in the second circle. If I do cross product of these two vectors, then I get the area. So better way to talk in area. If I want to say what is area, and I have two vectors, then better do cross product. There is no product of vectors. If I say P into P, that does not make any sense. P dot P or P cross product P. So cross product gives the area. So now we have magnitude of delta P ith section into delta P jth section. This multiplication, either it has to be dot product or cross product. So cross product will come because we are talking about area. So it is replaced now as magnitude delta P ith section in the circle where x is constant, where y is constant. Cross product delta P of the jth section of the circle where the x is constant. First y is constant, x is constant. Delta P cross delta P. Okay, if that is the case, then first one I can divide by delta x because x is variable, and second one I can divide by delta y because y is variable. To compensate to division, I have to multiply again. More or less, this form is becomes magnitude delta p by delta x cross delta p by delta y, and then outside delta x delta y. We had come to this stage in the previous video. Okay, now this is the ith or jth section. What is the area? Area is summation sign, summation. Now this is the area of the ith or jth. Okay, now now this is the area of the ith or jth section. Okay, now I'll keep continuing. Now if this is the circle and this is the circle, along the circle I have to go with the different section, and along this circle I have to go with. So every point, if I take any point here, then I cut in xz plane where y is constant, and then I cut in yz plane where x is constant in any way. Now in this fashion, then there would be, if I stop that, how many area is coming, I believe it will be I into j, something like that. So I can more or less say summation I equal to 1 to n, summation j equal to 1 to n. Make sense? And area of the ith jth section, if I go with this fundamental, it gives the full area. Okay, so j means I have cut this circle in yz plane into n part, and I refer it to jth part. Similarly, I cut this circle in the xz plane. I refer to a particular section as ith section. Okay, in that fashion, I have summation of I equal to 1 to n, then summation j equal to 1 to n, and area of the I comma j, ith jth section. If I sum it, then it becomes the surface area of the sphere. Okay, then what is the ith jth area? Ith jth area is magnitude delta p vector ith section by delta x of ith section. Means if I had taken a circle, okay, this is the circle. I took any point p here, and at p I made a circle keeping y constant. At p I made a circle keeping x as constant. Okay, in that fashion, this is the circle where y is constant. In that fashion, this is delta p. This is the delta p vector. If this is the point p, then at point p, tangential vector is delta p vector. Delta x means if this is the ith section and this point to this point, if I come down, then there is a gap here in x-axis, and that is delta x. Make sense? With delta x, if I make a delta x change in the ith section, then how much position vector would vary? That is delta p by delta x. Means position vector is dependent upon x-axis. Change in position vector is dependent upon change in x-axis, delta p by delta x. This proves that it is not p by x. P by x is pure division, and this is delta p by delta x. Change in x-axis that we see in the ith section brings how much change in position vector in ith section, delta p by delta x. Now, where delta p is dependent upon x, if I see position vector, then it is xi plus yj plus zk. It is a function over x and y. But y is constant we have taken in this circle. So more or less it is function over x and z. Z is z, x and y are independent component in sphere, but z is dependent component. Z square plus x square plus y square equal to a square, that is radius of the sphere. Z equal to square root or plus minus square root a square minus x square minus y square. That is the z. If that is the z, then z is dependent upon x and y is constant. More or less, x is only independent component, only variable component here. So now we have delta p by delta x ith section in the circle where y is constant. If numerator is dependent upon denominator, numerator is a vector and it is dependent upon denominator, then this is a fit case to transform into calculus. Okay, anyway, we will see it. Now we have I summation I equal to 1 to n, summation j equal to 1 to n. Make sense? And then we have magnitude delta pi by delta xi, cross product delta pj by delta y. In another circle, position vector is changing with the delta y. X is constant. Delta pi, delta pj by delta yj. Magnitude. So magnitude is a vertical bar. We talk about the its absolute value. And then outside we have delta x, delta y. Delta x belongs to ith section. And in this circle, delta y belongs to jth section. Now, if we watch closely, then this is the repeated summation. Summation means if I sum all the part, I made this area into n part. This full surface area I divided into n part, where n is this vertical, this xz plane circle. I chopped xz plane circle. I chopped into n part. YZ plane circle I chopped into n part. So n into n, number of area I divided it into n into n. Now if it is n into n, then it is summation I equal to 1 to n, summation j equal to 1 to n, and then area of the ith jth section, and that is magnitude delta pi by delta xi cross product delta pj by delta yj, magnitude delta xi delta yj. This is the ith section. Sum it full, you get the area. Can we now, when n tends to infinity, no one can infinity number of area, no one can add it. So we have to go to the integral calculus. Integral calculus means whatever we are calculating, it must be in a form of fx dx. That is integral calculus. Height by width. If I if I have a tendency to multiply height with the width, where height is a function over width, width is x-axis and height is function over x. What about height is constant? Still I can say function over x, but it has a constant value. Fx into x means y into x, where y is height and x is width. Y into x, where y is function over x. Fx into x can be converted into fx into dx, where it talks about the area formed by y. This is what we have seen. If I have x-axis, if this is x-axis, and there is a curve called function over x or y, if I do fx dx, then whatever the function over y I have, underneath whatever area comes hitting the x-axis, that is fx dx. Left limit, right limit, that will make a box. Function, this is a function. This is a function over x-axis. Hop, hop, hop. This is x-axis, and this is a function over x-axis. Function over x-axis. Fx dx will give the underneath area. Okay, from where to where? From point A to point B. It makes a line. It makes a line. Whatever comes underneath it, limit A to B, x equal to A to x equal to B. Function over x dx. This will give the area. This is the basic form of integration. How I can bring this repeated summation into basic form of integration? Then we can calculate the surface area. Summation I equal to 1 to n, summation j equal to 1 to n. That is all right. Now we have magnitude of delta p by delta xi cross product delta p j by delta yj. If I consider this as a function over x and y, certainly it is function over x and y. First, delta p is a function over x, delta p by delta x. That will come as a vector, function over x, cross product. Another delta p j is a function over y, because x is constant and z is function over x and z, where x is constant. Again, it is a position vector, is function over y only. Delta pj by delta yj is function over y. Altogether, delta pi by delta xi cross product delta pj by delta yj is a modulus, means magnitude. It is a function over x and y. I can write as function in bracket x comma y, function over x comma y, into delta xi delta yj. I can rewrite as delta xi yj. Delta x and y I can together I can write as xy plane, delta xy plane. Okay, now we have multiplication of two items. Now one is function over y, x and y into xy plane. If there is a multiplication of two items and first item is dependent upon another item and another item is independent, it is fit case to transform into integral calculus, provided there is only one independent component, not two. We have two independent components, x and y. Together, I can say I have one independent component called xy plane. Now it makes sense. Now we have fxy, that is the height. Fxy. So fxy, I can rewrite as z, any z, not that z we are talking, any z, or I can say alpha, alpha, fxy as alpha. Alpha is a value that comes after placing x and y into a function. It returns alpha. Alpha into delta xy plane I can write as alpha. So I'm sorry, fxy xy plane fxxy x comma y, that plane I read. I'm sorry about it. So we can write, I said fxy as alpha. Consider xy plane I am denoting as alpha. Then first becomes function over x comma y function over alpha, and delta xy plane is alpha, more or less function over alpha into alpha. It is a fit case to come as integral calculus. Integral calculus is nothing but calculation of area. Area. So we will go again. Integral calculus is nothing but calculation of area. If this is x-axis, this is function over x, that is fx, from point A to point B. There is a vertical line like this. Now it is integration sign x equal to A to x equal to B. Function over x into dx, that will give the area underneath it. Now it is up to me, from A to B I can chop into n parts. Consider I chop it into n parts, and each part I calculate the subsection area. If I add all the subsection area, it is again fx dx only. What are you trying to say? I am trying to say that if there is a function called fx, okay, consider this is x-axis, this is function over x. Now this is point A and this is point B. If I say integration x equal to A to B fx dx, it calculates area underneath it hitting the x-axis from point A to point B. This full area. Now I divide A to B into n different parts. And each part, what is the area of each part? if if I say ith part, then what is the fx at the ith part into the width of the that section? How many sections are there? From A to B I chopped into n section, where each section width is a minus b by n. If at any ith part, what is the height? Function over x, when x belongs to ith part, whatever it is, into a minus b by n, that is the width. I can call it delta x. So function over xi into delta xi gives the area of the ith section. If I add all, summation I equal to 1 to n function over x at x equal to x belongs to ith section x into delta xi, that is the width of delta x, that is the area of this section. If I add all the area, it becomes the full area only. So summation of I equal to 1 to n function of x, when x is at the ith section. What is the ith section? Ith section, if I say, then it is a minus b by n, that is the width of 1, into I, that is the x value there, function over x at ith section, into delta xi, that is the ith section area. Summation I equal to 1 to n function over x at x belongs to ith section into delta xi is the full summation, that is same as fx dx x a to b, same thing. Now we have come here, summation I equal to 1 to n, summation j equal to 1 to n, magnitude whatever we did, delta xi delta yj. Okay, in that fashion we rewrote it as fxy delta xi delta yj, or delta xi yj. Okay, now I term x and y plane as alpha, function over alpha, delta alpha. What is delta alpha? Delta alpha is delta xi delta yj. Okay, whatever it is. I can rename, if I have taken xy plane as alpha, then the double summation I can transform into single now, because x axis and y axis. Okay, we'll say. So this is x-axis and this is y-axis. Now this is xy plane. I took full xy plane as one independent component, not two x-axis, not two axes like x-axis or y-axis. One xy plane. That xy plane I am representing it through alpha. Now we have summation I equal to 1 to 1, summation j equal to 1 to 1. I can write now summation 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 some k equal to 1 to n, some k, summation k equal to 1 to n, function over alpha delta alpha, okay, kth section, okay, all together. Now it has come as summation k equal to 1 to n, function over alpha, alpha belongs to kth section, delta alpha, delta alpha of kth section. This comes to a fundamental as if I have a alpha axis, and there is a vertical axis called function over alpha. And in that alpha axis, I have chopped it into n different parts. And then this width is delta alpha. One width is delta alpha. Okay, I have taken kth section, the delta alpha kth section. Okay, in that fashion, this is a fit case to become integral calculus. Integral calculus because we have function over alpha, the way we said earlier, of the kth section into delta alpha of the kth section. If I have a function over any point function and multiply with the delta alpha, then it will give the area of the delta alpha. This sub area, if I add for all the alpha, it gives me function over alpha d alpha, the way we saw earlier. Limit from alpha one point to another point. Okay, someone can understand if I'm not very accurate in summation and this and that. Okay, it will now more or less become integration sign function over alpha d alpha integration sign limit, some we can place whatever the alpha it is. Makes sense? Now it will come, now we will rephrase it as x and y. Now integration alpha will turn into x and y. XY plane from from beginning to end, that is the limit. And function over alpha become fxy. And then d alpha become dxy plane because we change xy into alpha, dxy plane. Dxy plane I can rewrite as dx dy. More or less delta xi delta yj I transform into dx dy. And function over x and y, now it will come to its original shape, and that is magnitude dp by dx cross dp by dy. Limit is the xy plane. On the xy plane, if I take xy plane, then limit is a circular region, because if I take a sphere and sphere is centered at the origin, top of part of the sphere is above the xy plane and bottom part of the sphere is below xy plane. On the xy plane it will make a circle, so limit on the xy plane is a circular region. So if I integrate circular region on xy plane, dp by dx cross dp by dy magnitude dx dy, it will give the surface area. We will try it. Okay, let's demonstrate in better way. Okay, we are talking about two-dimension summation. It is little complex. The two-dimension summation means, consider this is x-axis, this is y-axis, this is x-axis, this is y-axis, and this is z-axis. In that fashion, if something like that, then this is the origin. Blue color is the origin. Now, if this is x-axis, then I divide this x-axis into n part. This is what we did actually, n part, and each and one of the part is ith section, that I refer as delta xi, because each section will have width of delta x. Similarly, y-axis I divided into n part again, and particular jth part I denote is a delta yj. This is what I go top on the sphere, then I say delta xi and delta yj. Make sense? Now, if I come to integration, now if I come back to repeated summation again. Summation of I equal to 1 to n means x-axis is chopped into n part. N part, summation of I equal to 1 to n. Summation of j equal to 1 to n. This is chopped into n part, j section we are talking. And then after that, we have function over x and y. Delta pi by delta xi dp by dx cross delta pj by delta yj, that is fxy, function over x and y. Function over x and y at the ith section of delta x and jth section of delta y. Wherever it comes, if I, this is x axis, this is the ith section of delta x. This is y axis, this is the yth section of jth section of delta y. Here it will come delta xi and delta yj. Top, if I take, it will hit the point P that we are talking about. Now the question is arising that we are trying to multiply fxy with delta x delta y, fxy with the delta x delta y. This is what we are trying now to calculate it. So this is something like that. What we were talking, that if I have delta x and fx, if I multiply fx with the delta x, and if I add for all the section, we have area, and summation of all area is fx dx. Same thing is now propagated into two dimensions. Now instead of delta x, we have delta x delta y. Instead of fx, we have fxy. So now if I have fxy that belongs to ith and jth section in x and y, and then we have delta xi delta yj, then it is again a fit case to come to double integration. But double integration is not the actual form of integration. Single integration is the actual form of integration. That's why rather than taking in two dimensions and delta and delta y confusing anyone, take xy plane as a single component. Xy plane as a single component. In that sense, delta xi delta yj transform into delta xiyj, delta xy plane. If I take as an independent component, then I have this axis as xy axis, and this is the function over xy. If I divide this xy axis into n different chop or n square chop, here we have n into n. I can divide into n square chop xy axis, and any section if I take, then here the height would be fxy. Fxy into delta xy. Delta xy, if I multiply, it gives the area of this section. If I add all those sections for the n square, it will give me the full area. That is nothing but fxy dxy. Okay, so this transformed into summation. Rather than taking alpha in between, directly we can do summation xy plane from begin to end fxy dxy plane. That will be break into, since xy are orthogonal to each other, dx dy. Now let's solve it. Now if I see xy, if I break the limit xy plane from begin to end, then if I had a sphere, if I had a sphere like this that was centered at the origin, then if I see this sphere that is cutting the intersection on the xy plane, it will be a circle of radius a. Now someone has to integrate now y, circle of radius a. So it will be a circle. It will be a circle on the xy plane. The intersection will be a circle on xy plane. Circle on xy plane. This circle equation in x square plus y square equal to a square. So y equal to plus minus square root of a square minus x square. Y is not a straightforward minus a to a and x is minus a to a. Now limit I can break, x is minus a to a, y is minus square root of a square minus x square to plus square root of a square minus x square. Okay, and inside it becomes dp by dx. dp by dx is I plus dy by dx, that is 0, because we have taken y as constant. I plus dz by dxj, cross product j plus dz by dyk. What is cross product of I plus dz by dxk? Cross product j plus dz by dyk, then magnitude. If someone does this cross product, I have done it many times. So it is minus dz by dxi minus dz by dyj plus k. its magnitude. Now dz by dx whole square plus dz by dy whole square plus 1 square root dx dy. Okay, what is dz by dx? What is z of the square? Z equal to square root of a square minus x square minus y square. Dz by dx whole square. Dz by dx is minus 2x by minus, it will become a square minus x square minus y square square root. If I differentiate with the x, then it will become 1 by, first I'll differentiate with a square minus x square minus y square. Okay, in that fashion, then it will become like 1 a square minus x square minus y square square root, that is to the power 1 by 2. If I differentiate, it will become 1 by 2, and then it will become 1 by a square minus x square minus y square. X square differentiation will be 2x minus 2 gone x. It will be minus x by a square root of a square minus x square minus y square. Dz by dx will become x square by a square minus x square minus y square. Altogether dz by dx whole square plus dz by dy whole square plus 1 square root will become x square plus y square plus a square minus x square minus y square. Net will be a square. A square, if I take square root, it becomes a by square root of a square minus x square minus y square dx dy and integration. Okay, first I'll integrate with the y. I can take out, keep a outside, 1 by square root of a square minus x square minus y square dy. Keep y equal to square root of a square minus x square cos theta. Then dy equal to square root of a square minus x square minus sine theta d theta. In that fashion, 1 by square root of a square minus x square minus y square will become minus a square minus x square. Okay, cos theta. I can take out the square root of a square minus x square outside, 1 minus cos square theta, 1 by sine theta. It will become 1 by square root of a square minus x square sine theta. And on top we have square root of a square minus x square minus sine theta d theta. All gone. Only minus will remain there. Minus I can keep outside. Now we have dx. Only dx. Okay. I'm sorry. Okay. No, I'm sorry. It will become d theta. Everything will go away. D theta integration minus d theta. Minus I can keep out theta. D theta integration is theta. Theta is from where to where? Theta is from where to where? If I have y equal to square root of a square minus x square cos theta, then theta equal to cos inverse y by square root of a square minus x square. If y is square root of a square minus x square, cos inverse 1, cos inverse minus 1, cos inverse minus 1 to cos inverse plus 1 means pi to 0, pi to 0. Then it will become a minus was there, minus pi, minus 1, pi will remain. Pi a I can keep outside. Pi, I believe pi a, it will be pi a, that I can keep outside. Okay, I don't know it will come correct or not. Okay, and then we will have dx. Dx integration is minus a to a, 2a, 2a. So 2a, 2, 2a, and we have outside, okay, I'm sorry, we'll try again. We have, okay, cos, I'm sorry, d theta integration is theta. Theta, 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 theta will go, theta is from cos inverse y, cos inverse y, cos inverse minus 1. I'm sorry about it. Okay, I'll do it again. So we have now at the end we came as minus a minus this side, and we have minus a outside, and we have d theta, where y is minus square root of a square minus x square to square root of a square minus x square. This is the y, and we have d theta. D theta integration is theta. Theta. If it is theta, then theta is lower limit to higher limit. Theta equal to cos inverse y by square root of a square minus x square. If y is square root of a square minus x square, cos inverse 1, that is 0. Okay, so upper limit is 0. Lower limit is pi because minus is there. Pi to 0 theta. that will become minus pi. Minus is outside and a is outside. It will become pi a. It will become pi a. Okay, if it becomes pi a, and then we have dx. Dx is from minus a to a. It will become 2a. It will become 2a. Okay, looks like I'm missing something. We will see it. Okay, so at the end, whatever it is, we have brought that the surface area, or we have to take it more meticulously. The surface area what we have calculated is dz by dx whole square plus dz by dy whole square plus 1 a square root dx dy, where limit whatever we said that is intact. This is the end we have came. dz by dx is x by square root of a square minus x square. dz by dy is y by square root of a square minus x square minus y square plus 1. Okay, if I do a square of it and settle it, it becomes a. It becomes, oh, outside was a anyway. Oh, I'm sorry. I think we did it. Okay, now we have the fix is a by, if I do it, it becomes a by square root of a square minus x square minus y square dy dx. If I take y equal to square root of a square minus x square cos theta, dy equal to square root of a square minus x square minus sin theta d theta. I have kept outside 1 by square root of a square minus x square minus y square, where if y equal to a square root of a square minus x square cos theta, all together it becomes 1 by square root of a square minus x square sin theta, and numerator is a square root of a square minus x square minus sin theta d theta. All gone, minus will remain. A is outside, minus a will come out. D theta integration is theta, and theta, okay, when we talk about theta, so theta is theta, then theta is pi to 0. This is what we have calculated. Theta is pi to 0. It becomes minus pi. It becomes pi a, and this side, the x-axis is a minus a to a, then it will become 2a. It becomes 2 pi a square. Okay, when we talk about x-axis that is going from minus a to a, okay, what is the surface area of a sphere? 4 pi a square. We have got 2 pi a square. Means when we are calculating x-axis from here to here, more or less we are getting half of it. Somehow it looks like I have to multiply by 2. That's it. So we have got 2 pi a square is the a square. 2 pi a square is the surface area. If I multiply by 2, means x is from here and it will come back to here. Looks like in this fashion. A from 0 come back to 0. Means whatever we have calculated, we have to double it. So the surface area of the sphere that is coming here is 4 pi a square. Right now it is coming 2 pi a square. If you multiply by 2, it will come as 4 pi a square. I have not checked it. I believe that is the surface area of the sphere, 4 pi a square. Okay, the methodology what we have used, that repeated summation to integral calculus, this is not available in any of the book. Please do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone number. All are research based.